Hello guys, welcome to my channel. Today we are going to talk about how to use a multimeter. This is a meaning of a multimeter. In this video I will show you how to use an analog multimeter or multi-tester. But before that, consider subscribing to this channel to support this channel. Thank you. The topic that we will discuss are different part and function and the procedures. Ohmmeter, DC Voltmeter, AC Voltmeter, and Ammeter. Now let's begin by exploring the parts and function of analog meter. This is the indicator pointer. Is the one that gives the meter reading. Well, this part is where we call the scale plate. Is where the scale of each meter is being located. This is the Ohmmeter scale. When we are using Ohmmeter in measuring resistance, this is where we should look for to determine the resistance reading. On the other hand, the voltmeter and ammeter scale is where we look for in determining DC and AC and ampere reading. Then this one is called zero corrector adjustment screw. Used to adjust the pointer to 0 at the left side, we can see a space at 0. To adjust this, we will turn it to clockwise direction until the pointer reaches to 0. Always bear in mind that the pointer is aligned to 0 at the left side before using the meter for the tester to give accurate measurements. Meanwhile, this part is called selector range. It is intended to select the proper measurement for intended measurement. For example, if we wish to use ohmmeter, all we have to do, point it to the ohmmeter setting. If you want to use AC voltmeter, just rotate the selector range on this part. When using DC voltmeter, you rotate the selector range here. When I use the ammeter, set the selector to ammeter on this area. These are the test probe. We use it to place the device of the component we are measuring. And lastly, the 0 ohms adjustment knob. Example, when using ohmmeter, we need to adjust to calibrate our meter. Let us set our meter to X1 range. We have to short the 2 test probe. As we can see, the pointer has deflected the right side of the meter scale. Always remember, when shorting the 2 test probe, the pointer must remain on 0. But this is not the case. We need to adjust it. To calibrate it by adjusting the 0 ohms knob. Just rotate the pointer slowly until the pointer reaches 0 ohms before using any setting on the ohmmeter. Calibrate the tester for it to give accurate reading. Move on how to use ohmmeter. The first thing we need to know when using ohmmeter, interpret the ohmmeter scale. See, there is gap in between which do not have indicated numbers. And it will make a number from 0 to infinity. Scale 0 to 2, the interval is 0.2. Or 2 to 5, we have 0.5. 5 to 10 is 0.5. 1 to 20, the interval is as 1. To 30, the interval is 2. 50, the interval is also 2. To 100, we have 5. From 100 to 200 as 20. To 500, interval as 100. 100 to 1k is 500. To 2k, we have the interval of 1000. If you don't want to memorize this table, read the ohmmeter scale in this manner. Example, in 2 to 5, difference between 5 and 2, which is 3. Let's count the number from 2 to 5. Here we have 1, 2, 3, 4, 5, 6 lines to get the differences of number from 2 to 5. By 6 we have 0.5. What we get is similar to the table. Count the line from 2 to 5 using 0.2 interval. Here we have 2.5, 3, 3.5, 4, and 4.5. Now let's have another example. We will interpret the range from 20 to 30. The number of lines from 20 to 30, we have 1, 2, 3, 4, and 5 lines. The difference of 30 and 20 is 10. Divided by the numbers of lines, we get 2. Is the interval of the range of 30 to 20. If we count the line as 20 as interval, here we have as 2, 22, 24, 26, 28. That is how we interpret the range of Ohmmeter. To different Ohmmeter settings that we can use to measure resistance. We have 5 settings: X1, X10, X100, X1K, and X100K. The common use of these settings are these settings. This setting stands as a multiplier. Then we get from the indicator pointer. We need to multiply it for the setting we are using. And if we set the Ohmmeter to S10, the resistance then equivalent to reading times 10 on the Ohmmeter also tells the maximum it can measure. For example, in an S10, the maximum resistance it can measure is 20k ohms. This is because the number we have in the Ohmmeter is 2k, that is 2000k. The product of 2k times 10 have 20k, 1000k. Now let's try to measure the resistance of this resistor. This resistor has 3.3k ohms of resistance. The setting we should choose must be capable of measuring these types of resistance. Here we cannot use X1 setting. The maximum resistor it can measure is 2k ohms. The setting that we can use can be either S10, X100, X1K. We just leave it at X10 setting. For using the Ohmmeter, you need to calibrate it to get the actual setting. The 2 test probe, then adjust the 0 ohm knob. And the pointer must reflect somewhere around here. As we test the resistor, we can see that the pointer reflects around 300 plus. As you can see. Therefore, the resistor is approximately 3.3 ohms. We move on to AC Voltmeter. Necessary to understand between AC meter setting and AC meter range. 3 meter range scale. These are 0 to 10, 0 to 50, and 0 to 250. When using the voltmeter scale, it must be according to the setting we use in measurement. For example, if we set the tester to 10 AC volts, the meter range that we should look for must be 0 to 10. However, if we set it to 50, we use the 0 to 50 range. 250 AC, 0 to 250 must be used. Why? When using 750 AC volt setting, where we use 0 to 10, but this time we will use a multiplier of 100. Whatever reading we get must be multiplied by 100 to get the AC value. So in voltmeter, it is a must to learn how to read a voltmeter scale. I will show you the different intervals every range. 0 to 10 scale, the volt stroke division is 0.2. 0 to 50, we have one interval volt stroke division. Now from 0 to 250, the interval is 5. However, if you wish to know how to get the interval in every range, then count the numbers of lines from 0 to 2 only, because we have a distributions of line in every meter range. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then get the difference of 2 and 0. It's obvious to be 2. Divide it by the numbers of line, that the interval is 0.2. 0 to 50, just divide 10 by 10. 0 to 50, you get 1 as interval. 0 to 250, therefore divide 50 by 10, you will get 5. In measuring AC voltage, setting that we use must be greater to the voltage that we use. For instance, let's try to measure an outlet. Let's vote. Here we are expecting a reading of 220 volts, but we must use a 250 or 750 volts. Volt setting. Using a 250 setting, connect the test probe to the socket outlet. As we can see, we have a reading of 230 volts. AC voltmeter, these are the settings that we can use. 0.1 setting, the meter range we should look for is 0.10. 0.01 as a multiplier. That is derived by dividing 0.1 by 10. 0.01. For 0.25, 0 to 250 multiplier 0.001. For 2.5, 0 to 250 as range, 0.01 as a multiplier. For 10 setting, 0 to 10, 1 as a multiplier. For 50 setting, 0 to 50 range, 1 as a multiplier. For 250 setting, 0 to 50, 1 as a multiplier. For 1000 setting, 1 to 10, 100 as a multiplier. 0 to 10, the interval stroke division is 0.2. 50, the interval is 1. 0 to 250, the interval stroke division is 5. Now let's move on to actual measurement. We have a 9 volt battery here. Let's measure the voltage across this battery. Now this is a 9 volt battery. We are going to set the tester to 10 DC volt. Connect the red test probe to the positive terminal and the black probe to the negative terminal. As you can see here, we get a reading of 8.4 DC volts. For DC ammeter, these are the settings we can use in measuring current. Have 0.25, 55 amp or milli, 2.5 milli, 50 micro. If we use 0.25 settings, the meter range we should look for is 0 to 250 multiplier 0.001. Set the meter to 25 milli. The meter range is 0 to 250. The multiplier as 0.1. For 2.5 milli, we still have the same setting, 0 to 250 range and 0.01 as a multiplier. Also, the value of current will be expressed in terms of ampere. Using 50 micro, 0 to 50 range, and the multiplier will be 1. Current will be a microampere. Now, since we know how to read a multimeter scale, let's measure a resistor with a 9-volt battery. I have 1k ohms resistor here. Let's measure it with a 9-volt battery. First, let's have a quick calculation using Ohm's law, that current is equal to volt stroke resistance. Here, current equals to 9 volts divided by 1k ohms, 0.009, 9 milliampere. Let us set the ammeter to 25 milli. We look at the meter range of 250 with a multiplier of 0.1. Expected reading we should get should be around 90. Since the product of 90 times 0.1 is 9 milliampere, using 25 milliampere, we shall express it in milliampere. Here we connect the black test probe to the negative terminal and the red test probe to the resistor that is connected to the positive test point. As we can see here, the pointer deflects on 90. Therefore, we have a reading of 9 milliampere. And that ends our analog multi-tester tutorial video. So now let's move on to digital multimeter. So this is a digital multimeter. That is the probe of the digital multimeter. When it comes to this multimeter, let's talk about the basic functions. We have the selector switch, we have the reading light, that is the light where you measure a transistor, the NPN, and you can see the PN transistor. A multimeter will come with 3 ports. There is a common port, that is the negative, this is the positive port. The basic setup of a multimeter. We will discuss one by one of the function of this multimeter. To start off, we are going to connect the red probe to the positive, which indicated the ohms and the diode there. Then the black to the COM port, which is black. We use this port for now. The commonly used port for measurement. So this is the range selector. You can see that is the range selector. We have two symbols here. As you can see, that symbol is for alternative current. Look at the symbol. Then you see this is a symbol of a DC current. A DC current. The DC, you can see the different setting. That is the DC, the ampere. You can see the symbol, the different symbol there, and this is the ohms. The setting. We have only 2 types of range, the 600 range and the 200 range. That is for the AC Voltmeter reading. As you can see, you can select it to the 200 range depending on what you want to measure, but normally an outlet you must set it to 600 range. Outlet is 220 volts, so the volt must be greater than what you are reading. The range that you are selecting must be greater than what you are reading. So 600 is the range you select if you want to measure an outlet. As you can see, the 200 is lower than the outlet. So if you want to measure a DC, this is 2 volt range. Supposing you are measuring a small volt like 1.5 volt, you can use that. Supposing you are measuring the volts you want to measure is almost 20, you can use the 20 volt. If you are measuring something greater than 20, you can use the 200. The same to the 600, depending on what you are measuring. Here, if you are measuring an DC current power supply, you can see the minus sign it always appears when the positive is on negative and the negative is on positive. It will show you the minus sign there, that the connection is wrong, that the positive is on negative and the negative is on positive. Here is used for measuring a resistor. When you set it on this range, that is for a resistor. If you want to measure a resistor, you can set the multimeter to this range, then you have a reading there. Then if you want to measure an ampere, a DC current ampere, you can use this range to measure an ampere. Now here, that port is for 10 milliampere. If you are measuring 200 milliampere, 20 milliampere and 2 milliampere, you can use these ports here. But if you are measuring 10 milliampere, this is the port that you are going to use. You can use this port, a very high current. But if you are not sure, don't try it. If you try it and you are not sure, it may damage the multimeter, because the multimeter here has a fuse. You exceed this range, the multimeter will be damaged, because you can see the 10 milliampere is on fuse, so it can only hold on 10 seconds. If you are not sure, don't use it. It can damage your multimeter. So the next we are going to talk about is the box ray, which is the continuity tester. So as we are talking about current, be sure of the volts you want to read before you can know the setting first. If you are not sure of the setting, you can just leave it, because let's just move on to the, as you can see the sign, there is a diode sign and a bus ray, a continuity sign. If you want to measure a continuity, a forward bias, and you can also use that range for a bias, a diode reading, forward and backward. We're going to use for a continuity. You can use that range for a continuity to measure a straight wire. As you can see, once you to give a sound with a light, that is a continuity, a buzz ray, and it will give a beeping sound. Then if you want to measure ohms, this is the ohm range. If you want to measure the resistance between 2 points, that is measure up to 2 mega ohms. This is 200k, depending on what you want to measure. That is a 20k, and that's a 2k for a lower measurement. You can always set it to that, or 200k if you are not sure, depending on what you are measuring. That's a 200k, and here you can measure DC of milliampere of 200. There's a different range we have on a multimeter if you want to measure a multimeter. So guys, thank you for watching. If you are new to my channel, please don't forget to subscribe and click on the notification button for more videos and more updates. Thank you guys for watching.